Welcome to the DIY Honda Garage channel. The DTC P0220-16, identifying an issue with the throttle position sensor B circuit low voltage, is relevant to the Honda CR-V 2023 and newer models. This diagnostic trouble code indicates that the output voltage from the TP sensor B is lower than a predefined threshold, suggesting a potential malfunction. The issue impacts the vehicle's ability to accurately gauge the throttle position, which is crucial for engine performance and overall driving safety. The Powertrain Control Module, PCM, is responsible for monitoring this sensor's output, and upon detecting abnormal conditions, it registers the DTC. Understanding this error code requires an awareness of the critical role played by the throttle position sensor within the vehicle's throttle body assembly and its connections to the vehicle's wiring harness. This presentation will cover detailed inspection and troubleshooting steps to efficiently address the identified issues associated with DTC P0220-16. The throttle position sensor B, TP sensor B, is integrated within the throttle body component of the Honda CR-V. Its primary function is to monitor the position of the throttle, which indicates how much air enters the engine, ensuring optimal fuel-air mixture for combustion. The signal it generates is sent to the Powertrain Control Module, PCM, which processes this information to maintain smooth engine operation. When the output voltage from TP sensor B falls below 0.3 volts, the PCM interprets this as a malfunction, leading to the registration of the DTC P0220-16. The PCM's role is vital, as it manages numerous engine parameters to ensure performance standards are met. Malfunctions in this sensor can trigger limp modes, impacting driving capability, as the PCM may limit throttle input to prevent potential engine damage. 4 primary causes can lead to the DTC P0220-16. Firstly, a faulty throttle position sensor B may not produce the correct voltage output due to internal component failure or damage. Secondly, an open circuit in the wiring can occur, which prevents the necessary signal from reaching the PCM. This can be due to broken or corroded wires. Thirdly, a short circuit could manifest, resulting in unexpected routing of voltage that causes irregular readings forwarded to the PCM. Lastly, a malfunctioning PCM could also be the root cause if it fails to process sensor signals correctly or if its internal logic is compromised. It is imperative to systematically check and rule out these causes when addressing the DTC. Several symptoms may indicate the presence of DTC P0220-16. First, drivers may experience engine performance issues, such as hesitation during acceleration or uneven engine behavior, which can compromise the overall driving experience. Furthermore, an unresponsive throttle may occur, leading to situations where the vehicle does not respond as expected to gas pedal input. Another possible symptom is increased fuel consumption, as the engine may adjust fuel mixture settings improperly due to inaccurate throttle position readings. Lastly, the check engine light will typically illuminate on the dashboard, serving as a warning to the driver that the vehicle's onboard diagnostic system has detected a fault requiring attention. Recognizing these symptoms early can facilitate timely diagnostics and repairs, thus preventing further complications. The first troubleshooting step is to turn the vehicle ignition to the on mode, which activates the vehicle systems without starting the engine. Next, connect the Honda Diagnostic System, abbreviated as HDS, to the vehicle's onboard diagnostic port. The HDS will showcase the current value of TP sensor B, which should ideally register around 5.0 volts when functioning properly. If the displayed value is less than 0.3 volts, it confirms that a failure is replicated. Validating the DTC P0220-16 diagnosis. This step is crucial as it helps determine whether the issue lies with the sensor's output or potentially with its corresponding circuits. A verified low value indicates that further inspection of the sensor's wiring and connections is warranted in subsequent steps. For the second troubleshooting step, ensure that the throttle body connector, designated as a 6P connector, is disconnected prior to testing. This is essential to prevent feedback that could skew test results. With the ignition still in the on position, utilize the HDS to verify the voltage output at the TP sensor B terminals. Ideally, this value should be about 5.0 volts. A normal reading at this stage indicates that the throttle position sensor is functioning properly. However, if the voltage is abnormal, this points to issues with the throttle body assembly or related components that may need further examination in the next steps. Determining the normal range assists technicians in narrowing down whether the throttle body or additional connected circuitry is at fault. During this step, continue with the inspection of the VCC3, THL2, and SG3 circuits while keeping the throttle body connector disconnected. First, ensure the PCM connector B is also disconnected before beginning your assessments. It's crucial to jump the SCS line with the HDS and wait at least 1 minute. This action prepares the system for accurate readings. Then, inspect the VCC3 open wire circuit for any disconnections. The normal reading here should indicate less than 1 ohm of resistance. Following that, evaluate the THL2 and SG3 circuits, ensuring there's no shorting. Normal conditions require more than 1 mega-ohm resistance. If these points reveal abnormalities, it indicates issues in the wiring or potential short circuits requiring repair. Engineers should utilize charts for guidance on open shorted wire inspections specific to each circuit inspection method. The final troubleshooting step involves inspecting the PCM for potential failures after confirming all previous components are functioning correctly. If earlier tests have all indicated normal conditions, the resulting diagnosis leans towards the PCM itself being at fault. This module is vital as it processes inputs from sensors and dictates engine operation. Diagnosing a PCM failure requires specialized tools and knowledge, as many issues are not evident through basic testing methods. Often, issues can stem from internal failures that are not accessible via exterior inspection. If a faulty PCM is confirmed, it must be replaced or reprogrammed by following manufacturer guidelines. Addressing PCM malfunctions correctly is essential to restore functionality to the throttle position operation within the vehicle. After completing repairs, it is vital to perform thorough final verification to ensure all issues related to DTC P0220-16 have been resolved. Start by rechecking the system conditions to confirm that the previously faulty components are now operating correctly. Following that, the DTC must be cleared from the PCM's memory using the HDS tool, ensuring that any old error codes do not interfere with proper operation. A thorough test drive should follow, allowing technicians to observe the vehicle's performance under various driving conditions. It's essential during this phase to assess if any warning lights reappear, particularly the check engine light, which might indicate residual problems. A comprehensive final verification solidifies that the repair procedures have been successful, thus maintaining optimal engine performance. Preventive maintenance is essential for minimizing the likelihood of encountering DTC P0220-16 in the future. Regular inspections of the throttle position sensor B and its connections can prevent unexpected failures. Technicians should also monitor the electrical circuits connected to the throttle body, checking for corrosion, damage, or wear that may lead to increased resistance or short circuits. Keeping an eye on engine performance metrics can also help identify anomalies early, allowing for timely interventions before they escalate into more significant issues. Keeping wiring and connectors clean and free from contamination aids in maintaining reliable communication between components. Finally, following the manufacturer's recommended maintenance schedule will provide an overall health check of engine systems and improve vehicle longevity. In conclusion, DTC P0220-16 indicates a critical issue involving the throttle position sensor B circuit low voltage within the Honda CR-V. Recognizing the roles of the TP sensor and its connection to the PCM is vital for effective diagnostics. Through a systematic approach that includes specific troubleshooting steps, from testing sensor voltage to inspecting associated circuits, technicians can efficiently identify the source of the problem. Understanding these components and their interactions allows for targeted repairs. Moreover, implementing preventive maintenance practices is crucial in prolonging the life of the throttle position system, ensuring fewer disruptions in the future. By comprehensively addressing both DTCs and their underlying causes, clinicians can enhance vehicle reliability and performance. Please like and subscribe to the channel. See you next time.